Hi, everybody, and welcome to How to CTF Infra, Beyond the Challenges and Flags. Oh, sorry, I appreciate the feedback. For a little bit of first-time jitters. Thank you, friend. Learning things every day. Thank you. So, hi, I'm Max. My pronouns are they, them, and I've had the fortune of working with Cloud Village and doing infrastructure work for them since 2020. A little bit about me. I'm from New York. I used to run a comic book store, and whiskey, fruit, veggies, love, peace, and coffee are a few of my favorite things. So we're here mostly because we've been running CTFs for DEF CON since 2019, and we wanted to share with the community. We've learned a lot about what we do that's successful, and a lot of things to watch out for. We want to share them, and hopefully everybody else who wants to run a CTF can come in forewarned and forearmed. Level setting, what is a CTF? You have a contest where a group of one or more people get together, break some things, solve some puzzles, learn a little bit, and grow as a security practitioner. And if you're doing it right, you get to grow as a human being as well. And the more CTFs there are, the better it is, not just for your small group, but for your community. You get to share and build a little bit of empathy and keep working on removing that stereotype of security as the Department of No. You have an opportunity for education and endorsement and including more folks with a little more empathy to do what you do every day. So when you're thinking about running a Capture the Flag contest, you're interested in, you're interested in a platform that allows users to register, to submit flags, to actually see the challenges that you're presenting to them, and a little bit of back end on your own. Make sure any errors are cleaned up, any malicious users can be banned. You need general administrativa behind the scenes for admin work. And so far, the tool of the day is CTFd. It is a really, really easy tool to deploy. The documentation is really solid. The dependencies are really well mapped out. And there was a competitor back in 2018 called FBCTF, but again, I say back in 2018 because the project has since been archived. CTFd is, for now at least, pretty much the only game in town. So CTFd is this framework for providing you the capability to host a challenge, to have users register, to have flag submission. And if we quote a little bit from GitHub, a capture the flag framework focusing on ease of use and customizability. It is open source, CTFd on GitHub, and it's created by Kevin Chung, who's Cold Heat on GitHub. If you're interested in running it on your own infrastructure, similar to what we do, that is absolutely a thing you can do. If, alternatively, you're interested in running a CTF, but maybe infrastructure engineering is not your passion or something you want to explore right now, they have commercial services at ctfd.io, if manage is more your jam. So the first time that the first time that I deployed this in 2020, here's a little bit about what it looks like. We've got our Elastic Load Balancer as our network boundary, everything else inside the VPC in AWS. We've got virtual machines running CTFd. We've got a remote email server, remote asset storage in S3, remote MySQL database running in RDS, and a remote session cache, running Redis and Elasticache. Everything we do is run in Terraform, one module per component. Terraform, particular infrastructure as code tool, built by HashiCorp. Since this particular deployment used virtual machines to host the application, we also use another tool called Packer, and that gave us the ability to stamp out repeatable known states from when we could then run an auto-scaling group. CTFd can, for very good reason, attract a lot of traffic, and you want to make sure that you have the capability to absorb that as you're going. Auto-scaling groups, in particular CPU-driven ones, which is what we tuned this for, give you the capability to have your fleet dynamically scale out, absorb the traffic, and slowly scale back in as your traffic spikes decrease. That way, you're not shooting machines in the head that are actively serving traffic, and you're also not paying for machines that are hanging out, not really doing a whole lot of work. What not pictured on the architecture diagram, one behind the scenes component that I do want to call out, AWS Secrets Manager. Kind of surprising nobody had storage secrets. Want to call it out because you need storage to provide database credentials. You need secret storage to provide your object storage access keys. Or at least as of when I put this together, they didn't support using IAM roles. Meh, feelings. And also, this one got me the first couple times I was deploying it. You need a secret key that every single instance needs to share. That way, all the cookies are signed correctly and the sessions can be accurately and consistently retrieved from the cache. Otherwise, things start getting weird and all your user requests will drop on the floor. People have to start sessions again and again. Very, very, very brief aside about infrastructure as code. I have feelings. I will contain them as best I can. Infrastructure as code gives you the capability to document and make consistent and known how you're deploying your infrastructure. You do it in code instead of words because it is generally the way that you talk to your infrastructure providers. And because it's code, you can read it, you can share it, you can have it code reviewed instead of just hoping somebody reads your bash script, and mine is pretty janky. So anything that makes it easier to read is always is always an asset. And excuse me. Terraform in particular, I enjoy because it is a declarative tool. That means you tell Terraform what you want to build, not how to build it. There are other tools that take that approach, but not so much my jam. Something that I do want to call out about Terraform in particular, it has the capability to pre-validate some of the configuration changes that you're deploying. Really, really, really useful when you're in development and you want to test to see, will AWS, for example, accept this configuration? It is quick feedback, and it is, again, a really, really powerful capability that Terraform provides you, mostly why I use it as much as I do. So the next year, in 2021, again, we have architecture with a public-facing load balancer. This time, CTFd is running in a different service, Elastic Container Service. It's a managed container offering from AWS. And remote email server, remote asset storage in S3, remote database in MySQL, and remote cache in Elasticache with Redis. And if you're wondering if that looks almost identical, that's because it almost is. The one component that we swapped out was virtual machines in the previous year for containers this year. It was a big deal for me because I wanted to make a stronger move towards accountability. If I provision VMs on the fly, I can SSH them and change them, and then forget exactly what I did to solve a problem. I've done that a lot, and I'd like to do less of that. Using containers forces me or any other engineer that you're working with to encode all of their configuration changes in the repo that you're using, and in order to deploy them, it cannot be done by hand. Let me say that differently. You could, but I would ask you not to. ClickOps is still real, but this forcing function helps for better traceability and better knowledge sharing across your team. Excuse me. Again, everything else is still stateless, so that portion of the configuration doesn't change. Instead of using auto-scaling groups for virtual machines, the Elastic Container Service has the same mechanics and has the same APIs, so we can reuse that logic. In particular, this time around, I didn't want to write it all from scratch again, so anybody doing infrastructure as code work can reach out to the Terraform registry. You have a library of currently existing modules and reusable knowledge, so that way you can either learn from code that's already been written, or you can pop it off the shelf the same way we do pip install requests and keep it moving. Also, I think worth noting, at least for me, in terms of cost savings, this year, for this deployment, we switched from using Secrets Manager to Parameter Store. It's cheaper. I like the UX. It's a lot easier to reason about. It's a lot easier to work with. And I don't know. Even though ECS has good support for both, my personal preference, mostly from usability and mostly from cost perspective. Excuse me. So how did it go? The first year we deployed this with virtual machines in 2020, we choked pretty hard during registration, actually. It was a pretty stressful time. The web page was crawling. Users couldn't register. Sometimes the page itself would just fail to load pretty hard. And I'm thinking, oh, cool, this is DEF CON. This is a really good problem to have. We're scaling. We're absorbing the traffic. The auto-scaling group will do its... And then the auto-scaling group didn't do its thing, which leads to a little bit more panic. Start looking at how the auto-scaling group is configured. CPU usage, which is, again, our scaling factor, really low. Okay, take a look at the database. Database is not doing a lot. Maybe the cache is choking. Maybe it's working really hard. also doing basically nothing. After a lot of panic and a lot of very, very high-speed documentation reading, it turns out the culprit is Gunicorn. Gunicorn is a, I hesitate to call it an app server because that makes people think of Java, but it is a web server that fronts Flask applications, and in particular, it was what we were using to deploy CTFd. Want to call it out because the default configuration is one thread and one worker. Really good, really clean for local development, good and clean for testing. Actually really terrible for production deployment. Once you've identified this, you can tweak the parameters as necessary and actually make use of the hardware you're provisioning. And once we figure this out and we're able to relaunch our fleet, everything was safe. Users are able to register, people can start reading challenges, flags can start to be submitted, and we are out of the woods for 2020. 2021, our first year running the Elastic Container Service deployment, it actually went really well. No issues to speak of, but we were not so lucky during 2022. 2022 brought us an issue where database connections aren't successfully closed from the application, inadvertently leading you to run the risk of denialing of service your own database from your application and knocking yourself on the floor. Super fun, something to be aware of. Watch your database connections as you're running CTFd. It needs love in terms of being container. It needs love in terms of handling signals appropriately. Something else that we noticed, and fun fact, also happened again this year, so it wasn't just a fluke. CTFd has what looks like a memory leak. It will run and run and run and progressively use up all available memory and then choke, even when it's doing nothing. Ran it for a week in development, just kind of hanging out, and it started to try and die. So something to be aware of. You can fix this by rolling your fleet semi-regularly. It is a workaround. It is not a patch that we've submitted upstream. And to that end, everything that we're doing while running these is live. All of the issues that we had to fix this year when we've hit similar issues is live. Everything that we hit for DEF CON in 2020 and 2021 also live. We don't have the luxury during a live event to take down, throw in PDB, and get really, really nitty gritty with the specific errors that we're dealing with, which is unfortunate because as interested as we are significantly more interested in making sure that our contestants have a platform and can have access to the challenges that we've worked so hard to bring them. So I've got things that I want for the future. Given the incidents that I just talked about, I'm really, really interested in better logging. AWS CloudWatch is what we're using by default with ECS, and previous to that, grabbing a bunch of log files. This isn't scalable, kind of surprising nobody. Having better log searching and having a better interface really for just how we ingest that information and parse it is something I'm really interested in. Separate thing about logging with like structured data, but we'll get there eventually. So that's one area of interest. I'm pretty interested in looking at Grafana Loki. It's a different way to ingest logs, particularly from containerized apps. Hopefully that could be a good use case. Time will tell. The other big area of improvement that I'm looking at is refactoring the infrastructure as code base itself. One option that I've been thinking about is using a tool called TerraGrunt. It gives the capability to provide a really, really strict dependency management. So instead of guessing which areas of code will impact others, you have very, very clearly drawn out scoping for each module and each component. Good for reasoning about it, good for code review, and also potentially this gives us the capability to provide better access control. If I have an engineer working on caching infrastructure, I don't necessarily need to give them access to the load balancer or the rest of the compute infrastructure. This is very much wish list, to be fair. An alternative approach to the code base that I've been looking at is using the cloud development kit from HashiCorp, effectively switching and using a general purpose programming language to create the infrastructure. Instead of using Terraform's declarative way of interacting with infrastructure, instead of telling it what you want, you would be describing each component and how it fits together using your general purpose programming language. For me, I work a lot in Python, so spend a little bit more time in an IDE, never a bad thing. I don't spend too much of my life in Vim as it is, but that's pretty much that. We'll see how it goes. I haven't made a decision yet, and For anybody who's interested in following along with what we've built, it's all online at GitHub. We are at Cloud Village, and the project is Cloud Village/CTFd infrastructure. Again, it is purpose-built to run in AWS. A lot of the primitives, I think, are reusable as far as the components that are available. And again, this is the shape it's got now. We'll see what shape it takes in the future. And now to talk about what we've got going on for this year, I want to bring on Jayesh. Oh, cool. I apologize. We do have a little bit for Q&A if anybody is curious about things.
Right here. How's it going so far this year?
So the question is, how's it going so far for 2020? Oh, God, what is time? I was about to say 2022 again. Yeah. 2023 is okay. The memory leak that I talked about and the database issue that I talked about both struck us this year. That is, I was up at 4 o'clock this morning fixing things. So on one hand, while our code base is solid, there's still, I think the application and potentially our handling of it might need some love in order to address those things. I like to avoid just shooting applications in the head if I can. So my hope is that sometime between now and post-DEF CON, I'll be able to spend some time doing local development and banging on it to figure out why we've got this memory leak. And the database thing is a particular thorn in my side, but I'm very much hoping for that. But that notwithstanding, this year is pretty good. So no new terrible things, just existing frustrations that thankfully we were already equipped to handle.
Are you implementing TerraTest at all for testing?
Cool. Sorry. So the question is, have we implemented TerraTest? TerraTest, for folks unfamiliar, is an infrastructure as code testing framework, primarily based in Go and from the same cats who built TerraGrunt, if anybody's curious. One of the reasons, actually, why I want to explore the refactor for TerraGrunt is to make it that much easier to eventually move to TerraTest. TerraTest requires your infrastructure as code components to be built in a particular way so that creating them and destroying them on the fly is relatively easy. This is very reasonable and also not frequently how you will find infrastructure as code deployed in anyone's actual production environment. So if you could do it, more power to you. I know it's always a work in progress for a lot of folks.
What database are you using, and where is the database? Is it?
Yeah, fair question. So question is, what's the database and where is it? CTFd supports MySQL. Theoretically, it supports Postgres. I say theoretically because it exists in the documentation, but it also says it's unofficial. So one's mileage may vary if you want to swap that out. We run our database in particular in RDS to manage a lot of availability, to manage configuration, and to manage, if necessary, failover.
Have you considered rewriting in Go?
I would not be so bold as to presume and rewrite a maintainer's existing project in a programming language I am unfamiliar with.
Okay, 2 questions. First of all, some types of web exploitation attacks will sort of destroy the state for all other users, like specifically cache poisoning, for example. Yeah. Have you ever thought of like a 1 container per team model or anything similar, and how would that work with auto-scaling?
So the question is, given that cache poisoning is a thing, how do you work around that, and what can you provide to still enforce team-level isolation for challenges? In particular, that's not something we deal with, and that has to do less with architecture and more with the specifics of how we host challenges, which is to say we don't. CTFd, it's an application. You can put stuff on the same infrastructure. One way that a lot of challenges are deployed with CTFd is if I have a VM running it, I can put all of my individual challenges on the same box for ease of use. Very intentionally, we don't do that. Every single challenge that we have is hosted on a different piece of infrastructure, entirely isolated from not just from the infrastructure as code perspective, but also from a networking perspective, specifically so that way if somebody does take out a component, it's not going to cascade it and hit the rest of them. I apologize. So that was one question. You asked the second one.
Yeah, second question. I was wondering if you've investigated, CTFd alternatives like RCDS or RCTF before, and what your opinions were.
Not yet, honestly. It is, in particular, I happen to be a little salty today, so I am very interested in looking at an alternative, but right now we have experience with CTFd. We have experience with its failure domains, which is something, I'm an infrastructure engineering gal, like I care a lot about my failure domains. So now that we're familiar with that, I'm not hesitant to change it, but I have to do a really, really strict evaluation of what I'm gaining if I decide I want to shift. Yeah, I think that's about that. Cool.